Welcome to video number 2 in the series Patterns. Today I want to talk a little bit about metals, nonmetals, and metalloids. So another pattern on the periodic table that you can see is there's clearly a little divide in between this huge chunk of blue and this chunk of green. And as it turns out, that's a really cool thing when looking at the properties of different elements. So what is called the staircase separates the metals, which are in blue, and look at how many of them there are, from the non-metals. And again, a lot of the non-metals are gas. Hydrogen, all the way over here. We talked about the noble gases and some of them here. But again, not all of them are, pardon me for that. Not all of them are gases. That's a common misconception. Like, oh, all the non-metals have to be a gas. That's not true. These in particular that I'm drawing are not. Phosphorus is a reddish powder. It's on the end of matchsticks. Sulfur is a yellow powder. Selenium can be a powder, but it normally looks more like a rock, but it's kind of got this little off metallic look to it. It's not shiny. And bromine is obviously an orange liquid. So a bunch of these other ones are gases, but not all of them. And you can see all the metals that you can commonly think of are here. Your zinc, your copper, your iron, lead, lithium, calcium, magnesium, all of them are in the metal family. What exactly does that mean? Looking at this, you're actually able to tell a lot of properties of different elements. For example, the nonmetals have stuff in common. The metals have stuff in common. And the metalloids or semimetals have something in common. And that something in common is this. When looking at the properties, I kind of like thinking about the metals first because you guys know about metals. Metals are solid, they are shiny, and they are good conductors of heat and electricity. Normally when people think conductor, they think electricity automatically. You also can conduct heat really well, and that's a cool thing. They are malleable and ductile. What that refers to is essentially, can you make it into a wire really easy? For example, getting a really big chunk of it and eventually making it so small that you can make a wire out of it. And can you hammer it into thin sheets? Okay, which again is like aluminum foil. You can do that. It's very malleable. And ductile is the wire. These are also normally positive ions that lose electrons. So again, if you have a positive charge, you're a cation, and you're losing electrons. Nonmetals are the opposite. They can be solid, liquid, or gas. They're dull. Powders normally aren't shiny. They don't conduct heat and electricity. They're brittle. They fall apart very, very, very easily. And they gain or share electrons, which is a negative charge. And if you're gaining negative things, you become negative. And that's a really, really cool thing about it. And you can tell that all from looking at this. All the metals have this in common. That's amazing. You now know something about every single one of these elements, even ones you don't know about. For example, like einsteinium. Einsteinium, which is over here, you know a little bit about it now, which is a great thing. And with the metalloids, it's important to mention, as I put this kind of in the middle here, they're the ones in the middle. And because they're in the middle, they have properties of both. They kind of are shiny, kind of not. Kind of conduct, kind of not. And that actually is what makes them semiconductors, which is the most important thing specifically about all the elements that are purple here. The most famous one being silicon right here. You might have heard Silicon Valley in California. Silicon is a huge reason why the technology that we have exists. And that's because silicon is a semiconductor. It conducts electricity, which allows my phone to work. But not that well. If my phone ran off electricity and it was primarily metals, it would fry because it would conduct the heat and electricity so good, my phone would get really warm and fry. Or there's a lot of heat and burn my hand or make me want to drop it. That doesn't happen here because it's just right. Think of it like Goldilocks and the Three Bears. The semiconductors mean it's just right. And that's my little video on metals, nonmetals, and metalloids or semimetals.